All right, welcome everybody to day 3 of Building for Digital Health, hosted by MIT Hacking Medicine in partnership with Google Cloud and supported by Apple Health. My name is Aditi Joshi, and I am your host and moderator for the week. So now we are in day 3 of our Tech Talks. It's a daily 90-minute series of Tech Talks all week long, which will culminate into a 3-day hackathon this coming weekend. Now, yesterday, you heard from Dr. Ken Mandel from Boston Children's Hospital, and he talked about the Smart Markers framework and gave history behind healthcare data interoperability. It's been quite the long road to get to where we are today, and a huge amount of progress has been made thanks to Ken and his team. And we've posted a ton of resources in the Discord channel so you can learn more. And we'll also do a deeper, more technical dive on Saturday at noon Eastern, so be sure to check that out. We also had Dr. Ricky Bloomfield and the Apple Health team talk about HealthKit, CareKit, and ResearchKit. And tomorrow is day 4 of our Tech Talks. We have the Google Cloud, Healthcare, and Life Sciences team with us. They are going to give you an overview of the Google Cloud Healthcare API and talk a little bit about how it leverages FHIR. So now you see we're building on the knowledge base from Monday's FHIR Tech Talk with Graham. And then we're going to do a little bit more of a deep dive into FHIR and an actual real-world implementation of it with the Cloud Healthcare API. The Google Cloud Healthcare API really provides industry standard protocols and formats so that you can ingest, store, analyze, and integrate healthcare data with cloud-based applications. After you get an overview of that, we'll talk about the Google Cloud NLP API, Natural Language Processing, and the Data Protection Toolkit. Now, I've posted all of these links in the MIT HackMed Discord server, so please do check them out before the talk tomorrow, and you can start posting your questions in the channel, and I'll make sure that the Google Cloud Developer Relations team will be available all weekend to answer your specific questions on these topics. Now, my goal this week is to equip you with the tools you need to have a successful hack this weekend and give you the opportunity to join a community of like-minded individuals who are passionate about democratizing healthcare one hack at a time. And if you want to get a complete list of the speakers, make sure you check out the MIT Hacking Medicine website or on the MIT Hacking Medicine Discord server. Now, if you registered for the event, you should have received a link from the team for this Discord server link. And so we encourage you to continue the conversations there. It's already been lit up after every single talk. So I want to make sure that we're really creating a community so that we can share resources and talk about some of the specific questions we have and get answers from each other. Okay. All right. Now, about today. Just to be fully transparent, this is very near and dear to my heart because I went through the Stanford Biodesign program as a graduate student at Stanford, and I am a big believer in the needs-driven innovation process. So let me introduce you to Oliver and the Cardinal Kit team. To give you a little bit of a background on Oliver, Dr. Oliver Aalami is a clinical associate professor of vascular and endovascular surgery at Stanford University and the Palo Alto VA. And he serves as the Director of Digital Health of Stanford Biodesign. He's also the course director for Biodesign for Digital Health, as well as Building for Digital Health at Stanford, and one of the co-founders of the open source project Cardinal Kit, which we're going to be presenting today. His primary research focuses on clinically validating the sensors in smartphones and smartwatches in patients with cardiovascular disease to unlock the potential for precision health. Now, how awesome is that? And with that, let's welcome Dr. Oliver Aalami to the stage. He's been waiting very patiently backstage. Hi, Oliver. Thanks so much for being here with us today.
Thank you, Aditi. Can you guys hear me okay?
Yep.
Okay, fantastic. Well, thank you, Aditi, and the organizers for the opportunity to present Cardinal Kit today. You know, it's a very impressive global conference, convening those with a desire to build solutions to improve healthcare delivery. So it's near and dear to my heart. And over the last few days, you've already heard Aditi talk about it. You've heard from literally the founding figures that have built the Lego pieces needed to release healthcare innovation at scale, such as Graham Grieve, the founder of FHIR, Ken Mandel, the team that helped develop Smart On FHIR API, as well as open source implementers of the Smart On FHIR from Apple and Android ecosystems, such as Dr. Ricky Bloomfield. So the stage is really set. When you're in my shoes as a healthcare provider and you're in the trenches, you really feel the pain and the challenges of everyday healthcare delivery and are desperate to build solutions to help make your lives easier and to also improve healthcare delivery. However, even in an academic setting such as Stanford, this can be quite challenging when you come with an idea without a development team and minimal funding. So I want to talk today about the promise of digital health, but also how CardinalKit was designed in an open source fashion to really help empower you to take all these Lego pieces that you've heard about over the last few days and put it to good use. So the agenda for today will be, I'll give a quick intro about my journey, and then we're fortunate to have the entire CardinalKit team of founders here. So Mike Hittle will give a talk about CardinalKit a little deeper. Then Varun Shenoy will talk about the resources and actually build a sample app, show you how that's done. And then Santiago Gutierrez will continue to take us deeper into the features, and we'll have some time for questions and answers. So really, the promise of digital health, let's talk about it. Some people would say that healthcare has left the building, the four walls of the established healthcare system, and moved outside into the community. So what's going on here? Well, it turns out we're on an unsustainable trajectory in healthcare with unsustainable rising costs, up to 17% of GDP spent in 2018, and this continues to go up year after year. Add to that despite, this crazy spend on healthcare in the United States, our outcomes are relatively poor compared to our neighboring countries that spend less, and that doesn't look good. Add to that the silver tsunami, or an aging society. We have a rising number of octogenarians and beyond throughout the country, in addition to the fact that we don't have enough clinicians, or we're not training enough clinicians to help manage all these people with these chronic conditions. So the government realizes this, and they're charged with trying to balance funding it with managing the patients and all the rest. So they realize this, and really any new innovation that is going to be funded or supported needs to really meet the triple aim. And what does that mean? It means that any new innovation needs to provide better outcomes at a lower cost and in a scalable fashion. Well, it turns out digital health is one way to be able to tackle certain parts of chronic conditions and healthcare delivery. What is digital health? We define it as the convergence of patient data, connectivity, compute power to increase access and provide personalized healthcare to improve outcomes at a lower cost. And then if you think of the framework, what is digital health? The patient's at the center. So that means that all this data, which can come in many forms and or shapes and forms, comes from the patient, is analyzed, whether it's an AI/ML model or even human analysis, and then is somehow applied to give value back to the healthcare delivery system. But when you, in Biodesign, this is a famous slide put together by Paul Yock, the founder of Biodesign, we not only really focus on a needs-based approach to innovation, but we also take great care to really make sure that whatever concept you think about addresses every stakeholder. And in most consumer businesses, it's pretty obvious who the payer is, and or who's buying the product and who's paying for it, things like that. Well, in healthcare, you're dealing essentially with an eight-headed monster. You've got payers, you've got regulators, you've got the government payer, you've had politics, and what digital health has added to the mix is the patient in their home, the patient outside the four walls of the hospital as a consumer of healthcare. So keep that in mind. There are also some other really high level enabling changes that have happened that I'll go into in the next 3 slides. The first is, and you've heard this touched on over the last few days. The first is data. You know, when during the Obama administration, even before, it was during the Bush administration, they noticed that they could not really measure the quality of care being offered or provided. And part of that was that all the data was not digital. It was you know, we had a lot of paper charts. So there was a big push to digitize the electronic health record. There's a famous consultant, Peter Drucker, who used to say, if you can't measure it, you can't change it or you can't improve it. And so that's what led to the 2009 HITECH Act with over $31 billion in spending to incentivize hospitals to adopt electronic health records. And this was done, you know, they implemented, there were some basic features that were required to be implemented. But what was learned over time is that, you know, this wasn't enough, and because it turned out the data was just sitting in the hospitals in these data silos and wasn't being liberated fast enough. Then comes along the 21st Century Cures Act and the final rule, which was as recent as March of last year, which you also heard about, where now the federal government has kind of blocked, formally laid down legislation preventing information blocking, and also has set the FHIR API standard as the standard for data exchange, and that all elements eventually will need to be exposed via an API. And this is just, you can't state enough how huge this is and what a big opportunity it is. And so again, instead of the government relying on the electronic health record companies to innovate, they're saying, you know what, let the developers such as you all out there build the innovation on top of the electronic health records, and let the patients be the stewards of their own health records as well. So a third but very important piece is that this is not, you know, I'll be honest, in the fee for service, you know, digital health, this has been around for a long time, but it's not really being adopted broadly. And why is that? Well, it turns out the incentives weren't quite aligned, and the government realized this as well. In the fee for service setting, it's the hospitals are incentivized to fill up the beds, you know, to have as many heads in beds as possible. Well, if you flip the equation and you pay providers and health systems based on value, keeping patients healthy, you encourage them to take on risk, then it really incentivizes them to engage patients outside of the hospital, keep them healthy. And that is really the sweet spot for digital health, is identifying, you know, where are these value-based programs, these alternative payment programs that CMMI and CMS and the government is really pushing. And the numbers keep going up every year in terms of the number of value-based delivery programs that exist across the country. And these can be in the form of Medicare Advantage, accountable care organizations, integrated delivery networks such as Kaiser, Intermountain, and so on. So really, the bottom line is, you know, the patient is going to become the key to unlock the health data. And the term that's being used is this consumer-driven or patient-authorized data exchange through these FHIR-based APIs that we've been discussing. So with the patient's permission, any third party can have access to the data and provide significant value to improve the patient's experience. I'm going to talk to you quickly about my journey and how it led to CardinalKit. I'm a vascular surgeon. I deal with patients that have blockages in their arteries, and we place a lot of stents in these arteries to help improve circulation. The problem is these stents fail often at 6 months, 12 months, so pretty quickly. However, we treat everybody the same. We put everyone in the same bucket in terms of surveillance, and we monitor them at 3 months, 6 months, and a year. But the reality is that people scar at various rates. Some people scar a lot, some people don't scar a lot at all. So some fail, some don't. And it was really frustrating in the emergency department to face these patients and hear them tell me that, oh, a few months ago, I noticed I wasn't walking well, but I thought it would go away and I didn't come in. So I thought, is there a better way to monitor these patients? And so I, came up with this hypothesis, what if the disease burden correlated to activity level? Can this be is there a precision health approach or opportunity using smartphones to passively track activity? Well, it took me from concept to the start of a study, it took me 3 years and over $120,000. I had to, just like anybody else, I had to deal with the research IT to get the right approvals and learn a lot about how to do things. I had to go get an IRB in with a compliance office, fill out a data risk assessment. And it was like learning, starting from ground zero. Eventually, we're able to get a bunch of studies off the ground and get approvals and so on, but it was very, very time consuming and cumbersome. And what we wanted to do as a team, as well as some of the other team members that you're going to hear from today, is let's open source, all the work we've done and make it easy. It started with the Stanford community, but now we want to open it up more widely to really lower the threshold so you can at least get an MVP out, test your hypothesis, iterate quickly, and have a good starting point. So from there, I'm going to stop here and hand it over to Mike. He's going to give you a great, deeper overview as to how CardinalKit can provide value to you, your healthcare organization, and so on. So Aditi, if you could pass it on to Mike. Thank you.
Great. Thanks so much, Oliver, for a great introduction to digital health for everyone. I feel like you captured my thoughts exactly. Give me 1 second and I'll go ahead and share my screen. Okay, so my name is Mike Kittle. I'm a doctoral student in epidemiology at Stanford University and one of the co-founders of CardinalKit. And so you might be asking, what is CardinalKit? And as Oliver said, we come from a team that has been innovating in digital health for a few years now. And, we have had to deal with a number of different obstacles. We've had to kind of bushwhack our way through it. And so in many ways, the goal with CardinalKit is to, kind of lower that activation barrier for other people. So if we look here, here's the 6 main ingredients of kind of an average digital health app. You start off with informed consent, ensuring that your users understand what they're getting into and what will happen to the data and what risks might be associated with enrolling in your study. And then we have surveys, which are pretty typical instruments that are used in digital health apps. A lot of apps will go ahead and capture sensor data, whether it's accelerometer data or other sensors that might be on your watch or your phone. So then there's a layer of kind of motivation and adherence. So how are you going to remind people to do whatever it is that you want them to do, in the application, whether it's through a text notification or a reminder or a phone call. Now, once you've kind of given your application to users and are starting to collect data, you need to do something with that data. It doesn't do any good to just leave it on the app. And so you need this data pipeline. And that's where things get a little sticky because not only do you have to collect and transmit this data, but you have to do it in a secure fashion. And then you've got analysis. So once you've collected and kind of modified the data and transformed it into an analyzable format, you then need to analyze those data. And at the end of the day, that's a really, really tall order. To expect a team to do this for kind of a pilot or an early stage concept, it costs a lot of money. And it takes a lot of time. So Oliver, talked about the amount of time and money that they spent kind of developing the first versions of Fast Track, and I can confirm that most digital health apps cost a tremendous amount of money and take a long time to launch. So you might spend $200,000 if you'll be externally having the developers work on your application. And this is something that most people don't understand as they're kind of launching out to pursue their digital health application, is that it's much more cumbersome and challenging than just hiring an undergraduate developer or hiring a developer to build the app. So not only does it cost a lot of money, but it also takes a tremendous amount of time. So with this study, the average development time is about 15 months, and so most apps actually need 2 years to launch. And this is simply an untenable schedule, really, for a lot of people in academia, a lot of research labs, or even startups that are looking to get out there and get a concept out there and iterate very quickly. So our goal with CardinalKit was to kind of build you a cable car. we had been through some of these challenges and started, at sea level trying to kind of summit this mountain. And really felt like, there's some repeatable kind of templated code that can help you get there. There's some infrastructure choices that we can make using best practices and partnering with groups like Google Cloud that could, give you a bit of a head start. So we don't necessarily want to take you to the top of the mountain, but we want to get you, maybe to a higher level base camp where you don't have to kind of go through all the trials and tribulations that we had to go through very early. And so that's really what CardinalKit is. It's an open source platform and code base for digital health research and applications. We leverage the user experience and user interface features that are kind of native to iOS and ResearchKit and HealthKit, and couple that with this really robust and incredibly secure Google Cloud backend. So what really is it? Well, it's a compliant starting point. So it's HIPAA ready. That'll save you possibly $150,000 in 12 months of development time. Again, we don't take you all the way to the top of the mountain. There's still some work that needs to be done. You still need to have a developer on your team. But with what we're providing here, you can really save a lot of those learnings that we've had to go through. And what we do is we leverage existing code to connect these critical services. So we're connecting ResearchKit with this hyper secure Google Firestore backend and Google Cloud backend. We have it's an open source project, and so the code is easy to fork and customize and kind of build to suit your purposes. Now, with us at Stanford, we have a university IT managed backend that kind of provides that other component of HIPAA compliance, which we'll touch on a little bit later. Most universities, most people that are going to be doing research on human subjects are going to have these types of researches. You'll have a research IT type department that can help you manage this backend in a HIPAA compliant and secure way. So, there's two kind of main silos of CardinalKit. There's the front end, which again, we're leveraging, these really wonderful services that are provided by kind of native iOS. So watchOS and ResearchKit and HealthKit and all the sensors that you might find on an iPhone or an Apple Watch, and connecting those with a HIPAA-ready backend provided by Google Cloud. So we're using cloud identity to ensure that the people logging into the app are who they say they are. And we're using Google Cloud Storage and Firebase and Firestore and Google BigQuery. And see, once you get the data into these services, you kind of open up this entire ecosystem of services and kind of infrastructure that can help you even analyze the data and present it back. So this is our general pipeline and architecture with CardinalKit. So we use what's called a serverless backend, which is that Google Cloud component. And so we leverage the Firebase SDK and tools on the iOS platform, use cloud identity for authentication. And then, once we have kind of gathered the data in a secure manner, we push those data to Google Cloud through Google Cloud Firestore. And again, once it's in Firestore, we can push this data to Google BigQuery or any other number of HIPAA-approved BAA-ready Google Cloud services. And so here are a few of the kind of like the key components, or at least the value that we feel like CardinalKit delivers to most research groups. We have a number of common medical surveys and instruments. You can collect passive data and active data through the sensors and through Core Motion, and then pipe those data into the Google Cloud platform. When you start using CardinalKit, you're also becoming part of our community. And so our goal is not to provide a service for everyone as much as it is to build a community. And so we welcome any input that you might have. If you notice something in the code base that you feel like it can be improved, if there's a feature that's missing, we strongly encourage you to join our Slack channel and to communicate with us, join our office hours, join our GitHub repo and submit your own feature requests and work on your own features and submit your own pull requests. There's integration with a Bluetooth kind of harness to collect data from exogenous Bluetooth devices. And we also, again, provide offline support. So there's a layer of kind of data integrity management to ensure that when your phone might not be connected to the internet, your data isn't lost. Now, I just want to touch on this. This is just one part of the HIPAA equation. So, there's 7 kind of core elements to HIPAA compliance. And the purpose of this presentation isn't necessarily to dig too deeply into these. If you want, can to kind of discover some more resources, you can follow this link to Google Cloud and kind of understand, the elements of HIPAA compliant that they deliver. But in choosing Google Cloud, we realize that we're leveraging possibly the most secure infrastructure on the planet for storing highly sensitive data. The job isn't done when you use Google Cloud, but there's still things that you as a researcher and that your research IT department has to do. But we get you as close as possible by leveraging Google Cloud resources. And again, I'd highly recommend that you follow the link here to kind of explore what HIPAA compliance in Google Cloud means, and what wonderful services they deliver to help secure your data. And that kind of touches on this other element where with HIPAA and with being HIPAA compliant, there's what's called a shared responsibility. And so this basically means that everybody that's working with these data has a level of responsibility for securing the data and ensuring that it's compliant with the state and federal regulations. And so you can see that this is broken down to, what are Google's responsibilities, or what's Google Cloud's responsibilities? What are your responsibilities as the team? And what are the responsibilities of the iOS app and even the patient? So you can see that this is kind of a shared responsibility. So again, just because you're using these services doesn't mean that you're compliant, but it's as close as you can get with with the technology kind of a piece of infrastructure. So here's just a handful of examples of applications that are using CardinalKit currently. We have Fast Track, which is, I think Oliver mentioned this a little bit earlier. We have an early intervention tool for opioid use called S-Smart. That was built, one of the earlier apps built on CardinalKit. We have another application that was that's built for advanced care planning and advanced care directives. And we also have an application called NeuroCoach that's built using elements of CardinalKit that's focused on stroke and neuro rehabilitation. And here's a quick demo of some of the basic components of CardinalKit. And so here we're looking at S-Smart. And so this is that onboarding phase where we're going through informed consent. And so we're going to go and agree to the IRB type terms and go ahead and sign up. And this is something that, with some simple modifications, as you'll learn later with Varun and Santi, to the settings file, you can launch your own application in just a matter of minutes. And so this is that two-factor authentication process. This is one form of two-factor authentication. We've added a few more flows since then. And voila, here you have a user that's participating in the study. And here we have some basic surveys that the user is going to go through. And again, all of these elements are kind of baked into the application, kind of ready to use just by modifying a settings file. So you literally could build a very similar application, maybe even in an afternoon, barring any kind of exogenous, kind of unique surveys. And so let's see here. We'll kind of breeze through this and then just kind of look at some of the settings that are in the back end of the application, so the patient can actually change their passcode or understand a little bit more about an FAQ and things like that. So ultimately, again, and I touched on this earlier, we don't want you to just kind of fork the code and go away. We'd actually really love for you to join our community. We're trying to build a community here, and we're trying to build a community that wants to help us accelerate digital health, not just in your backyard, but around the world. And to join that community, it's very simple. Go to cardinalkit.org. You can join our mailing list, fork the code base, and start playing around with it. Today, you're going to be working with Varun and Santi, who are going to walk you through how to build your own Hello World digital health application in 60 minutes. So I'd encourage you to watch those tutorials and find a feature that you like or that you want to work on, and submit your first PR. Again, we're really excited to welcome you to our community and to innovate and accelerate digital health together. So with that, I'll go ahead and pass it back to Aditi or to Varun, and thank you for your time today. And yeah, thanks for participating.
Awesome. Thank you so much, Mike. Okay, Varun, the stage is all yours.
Awesome. All right. Hello, everyone. I'm Varun. And today I'm going to be showing you a little bit about CardinalKit. So right now I have the cardinalkit.org website pulled up. We have a lot of really cool features you guys can check out here. We have a full documentation. So if you're interested in just setting up an app and getting started, you can head on over there. From downloading the bare basic software to actually setting up the database, as well as customizing the app itself. Moreover, we have our mailing list and Twitter. You guys can go ahead and follow us. And we have a bunch of forms you can fill out if you're interested in helping out on CardinalKit or helping out a team. And finally, we do have some community features you guys can check out. And now I'm going to go ahead and show the GitHub. So CardinalKit's an open source project, which means you can just go over to the GitHub and download the initial starter project. I'll show that in a second. Yeah, we also have a feature list under the issues tab in sort of the spirit of open source. If you have any ideas for CardinalKit, or if you want to contribute, you can always create a new issue or pick up on one of those which already exist. Okay, with that, let me go ahead and share my entire screen. Okay, awesome. So what we're going to do now is we're actually going to go ahead and run the CardinalKit sample app. So I have Xcode open. This is the CardinalKit app that I downloaded. And you can go ahead and go to CardinalKit example and open up the CardinalKit XC workspace file. From here, I already have the app running on my phone. So let me go ahead and pull it up. Cool. So this is the first launch screen that shows up when you log in. There's a little bit of information you can learn about the study, but we can go ahead and join the study. CardinalKit has a full consent form process that walks your users through with as many steps as you like. And at the end, there's a compiled PDF you can agree to. Go ahead and fill this out. And right now we have sign in with Apple enabled. So you can go ahead and click. I'm just going to use Face ID to log me in. It's going to ask me to create a passcode. So you guys can't see this, but on my end, there's actually a numpad that's popped up. Go ahead and confirm my password. And I was going to ask to read particular activity data. So for example, this app in particular wants to look at flights climbed, heart rate, steps, and walking plus running distance. And this data will be collected and stored in the Firebase that you set up for your CardinalKit app. So let's just go ahead and turn everything on. And it also has health records built in. So you can go ahead and click into it. And we can look into it. For health records specifically on iOS, you do have to go through and accept everything. I actually don't have anything saved on this phone right now, so I'm okay with sharing it. But you can walk through the whole process and it automatically gets uploaded to the Firebase database that you would set up if you walk through our documentation. So now we're in the app. We can go ahead and there are 3 surveys right now. We can go ahead and take a very simple survey question, which is a very basic patient questionnaire. So I'm just going to walk through the questions, just answer them. Boom, we're done with the survey. We can also take an active task, for example, for gait and balance. And what this is going to do is you can walk 20 steps and get started. And it's going to ask to track your motion and fitness activity, but that's okay. Okay. There's also a built-in CardinalKit panel. So if you want to schedule any particular tasks for a specific day or want to provide some sort of daily goal, that's really easy to bake into the app right here. Contact, if you want to contact your doctor right away, that's another section that's really easy to customize. And finally, profile. Here you can view the consent document that you actually signed earlier, right here. Or you could even upload your health records. So we already went ahead and we filled out one particular survey. So we can go into the Firebase Cloud Firestore, which is where all your data will be saved. We can go on over to the CardinalKit sample app. As you can see, my patient ID here is right here. And I'm just looking for a match, which looks like this is the one. And if you look at surveys, you can see that a survey task assessment has been complete, which is exactly what I filled out earlier. So that's been instantly sort of serialized into sort of a data object and stored onto the database. Now what we're going to go do is we're going to play around with the app a bit more. So we're going to stop running. Okay, yeah, that's fine. We can just leave that there. And we're going to take a look at this very special file in the app called the ckconfiguration.plist. What this does is it allows you to specify particular details in the app that could do with design, maybe text, consent, how you want to log in, and without having to write a single line of code, it automatically sets up the CardinalKit sample app to work the way you want it to. So for example, for onboarding, we had sort of those 3 slides that you see right when you open the app. Those are completely customizable. You can change the logo, the text, etc. The particular data you want to read, you can change that as well. You can add or remove sections in the consent form and change exactly what they say for your particular study. You also don't necessarily have to use sign in with Apple. There's also support for passwordless sign-in, such as in the example that Mike showed earlier. Or if you just turn both off, it'll just default to email and password. Yeah, with that, I already have a CK configuration file that I have set up for this particular demo. So I'm going to go ahead and swap them out. So now we have this one being our new CK configuration file. And there's going to be a couple of changes here you will see when we run. And finally, what we're going to do is we're going to add one more survey. So we're going to go ahead and just comment out a couple of these lines of code I have in this task item file that takes care of the surveys. So what we want is we wanted to have a title. It's going to be a coffee survey. It's also going to have a subtitle. It's going to have a unique image that that we have already imported into the assets.xc assets file. It's going to show up in a different section. Cool. I think that's all we need to do now. And we can actually go ahead and run the app again. So I'm going to go ahead and delete the app. I'm going to reinstall. Should be very quick. So if we actually go ahead and look into the CK configuration file, there's some very basic changes, such as there's a different study text title, different email, and different colors. We'll see that right away. An entirely different set of health kit data to read, and you'll see the unique icons and gestures for that. Let's see. And now we have 4 different elements for onboarding instead of 3 before. So again, sort of the pager view that shows up when you first pop up the app. And finally, actually not going to use login with Apple. And we're not going to use login passwordless either. Instead, we're just going to use signing with email and password. We'll show how that actually works out. Okay, now we're just waiting for this to build. In the meanwhile, we can take a look at some of the files that are actually in CardinalKit. So there's not just a configuration file. When you're setting up Firebase, which is the database we use, there is a Google service file that you'll have to import yourself. And we have a bunch of code that deals with sort of the UI. So all that stuff you saw. But also we have a full-fledged CardinalKit library and framework that deals with sort of how do we actually get this data onto Firebase? How can we read, for example, from some Bluetooth devices? There are a lot of very robust features that we're looking to build into CardinalKit. And now we have the app launch. Cool. So right off the bat, it looks completely different. You have a whole different number of sort of slides in the beginning. Go ahead and join the study. It's a much shorter and different consent form. Agree. Let's fill this out. Now we can sign up using email and password. Okay. And the password is actually going to be ask you to have particular characters and capitalized and whatnot. So let's just make sure that, let's just put that in again. Cool. It goes ahead and it creates a user. You can actually see in my Xcode, it's gone ahead and done that. Go ahead and log in. Press login, not forgot password. But sort of those features for like resetting the password, that's all built in automatically. You just have to enable it in this file. Okay. Health data. Let's turn everything on again. Ask about health records. Just go ahead and say not now. And we're ready to go. As you can see, we have a whole new survey that shows up. And we actually don't have CareKit or sort of the contact view anymore. Let's just go take the survey. Still early in the day, so I'm still on my first cup. Let's get that coffee tracked. And now let's look for the data. We're going to profile, look at the patient ID. We're still in the same app under the same bundle ID, so the user should show up here. Let's go ahead and refresh. Yeah, and it also says document successfully written, so you know that the data has actually been stored to Firebase. Okay. So user, surveys. As you can see, there's no CareKit collection. If any of you saw that earlier, that's actually gone because we've disabled CareKit. And we have our coffee task with the exact information that we wanted to have. So that's a little bit about CardinalKit and how you could use it to set up an app very, very quickly for your research team. Thank you.
All right. Thank you so much, Varun. I appreciate it. I'm going to move Santi to the stage.
Thank you, Aditi.
And share your screen.
Thank you so much. I hope that all of you are as excited as we are to learn about CardinalKit and get pumped for the rest of the Digital Health Hackathon and the apps that you'll be building. Today, I want to take us into a little bit of a discussion of what is in CardinalKit. We've learned a lot about this amazing framework. Hopefully, for a lot of your projects, you might find that you have some ideas as to what to work on, as to what to do, and you're seeking out to see, are there any individual pieces from different frameworks, different things over on the internet, different concepts that I know of or that I can ask of, that I can kind of pick and choose, cherry pick to build my tools, to build my framework, to build some of the innovations that you'll be introducing throughout this week. This little section and these next couple of slides might give you a sense as to, or might invite you to think a little bit about what is it that I want to build, and are there any individual pieces from something like CardinalKit that will help me get there? Whether or not you use all of it, hopefully this gives you some insights as to where you can look and a little bit about the shape of the CardinalKit framework as well. So let's get started. So we'll go ahead and break down some of the tools and services using CardinalKit. You've seen our website. Thank you so much, Varun. We just did an awesome dive through of what that looks like, our documentation, our community, our resources, and blog. After this build-a-thon, we'll also go ahead and send some links to our Slack. We do have a public Slack channel, all things CardinalKit. Truth be told, you are welcome to come there and ask any question related to digital health and the creation of technology in the digital health space. We are eager to help, and chances are that if we don't have a solution for a problem that you're facing yet, we're willing to talk it through and help point out some of the different ways by which you can accomplish that. So let's continue. CardinalKit as the team has described so far, is a very powerful suite of tools created to build your healthcare experience, to help you build your healthcare experience from the ground up, from the app itself to storing collected data in the cloud. So we saw GCP really briefly. We live and breathe behind GCP, the security and the tools that GCP offers, more so than anything. We also embrace and hope that you embrace as well the serverless model, in which we have applications and tools that connect with individual services to get really, really, really meaningful tasks done. I like to show this list and kind of leave this resource and link out there. It shows actually, let's click through it so that we can get a sense of the breadth of what GCP supports under HIPAA compliance status. We'll look through some of these tools today, some of which we've already seen, such as Google Identity to authenticate our users, cloud storage, the Firestore database, the Cloud Haircare API. Hopefully this gives you a sense as to what GCP products are covered, not just under BAA, but are considered HIPAA compliant for you to start trying, testing with, and building your apps around of. I was amazed to see a growing list of really awesome features out there to leverage. CardinalKit itself is meant to be a didactic tool. The goal is to teach you and anybody else that's interested in building a digital health app about what kinds of services they might want to interact with, they might interact with, and hopefully set the stage for you to ask questions as part of as how to build X, Y, or Z. All over here on this slide, all the way to the left, we see here kind of an instance of the Firebase SDK and tools. We greatly encourage that when you're developing your applications on iOS and on other platforms, you leverage the well-documented and the well-built Firebase SDK to connect and interface with the Google Cloud Platform. CardinalKit has some really powerful examples for you to give you different ways to authenticate. So in your app, if you're thinking about, okay, how can I have my users authenticate to my app, my patients, my users, or whoever it is that you're targeting, and how can they do so safely? We invite you to take a look at CardinalKit's implementation of Google Identity. We provide 3 tiers. One of it is the signing with Apple. The second one is the traditional email and password signing mechanism. And the third one is a passwordless login. A passwordless login lets you enter an email address. Your patients or your users will receive an email with a link to approve their account. When they go ahead and click on that, it takes them back to the application and locks them in right away. All of these processes, all of these tools are already baked and built into CardinalKit for you to experiment with, try each one, and ask the question of which one is the right one for your patient population. Once we start to kind of leverage the Firebase SDK and overall the GCP tools and services, you'll see how it becomes really easy to interface with individual services, kind of alluding to the serverless architecture. Firestore DB is the primary database that we use with CardinalKit, and we encourage you to use it as well. Is a standard NoSQL database. It is HIPAA compliant. Towards the end of these slides, we will get you thinking a little bit about how to secure it. What kinds of rules can you use to make sure that your data is protected there? Same concept applies for Google Cloud Storage. We encourage using Google Cloud Storage for bulkier data, sensor data specifically. You might be processing zip files. CardinalKit does a phenomenal job at collecting sensor data from an iPhone, device motion, core motion, accelerometer, gyrosensor, pedometer, etc. CardinalKit goes ahead and streams 10,000 records per file, creates multiple zip files, zip file number 1, zip file number 2, zip file number 3, and sends it out over the network to Google Cloud Storage. If your phone does not have an active internet connection. It will actually save the file on the iPhone, on the device. It will save a record to it, and it'll try again when you are connected to the internet. There are a couple of other really powerful services, such as the Google Cloud Healthcare API, which we heard earlier from Aditi, and Google BigQuery, which you can use for data analysis and processing. We'll give some insights as well as to how you can use the Google Cloud Healthcare API. It is a really, really, really powerful tool to help you collect electronic health records and process them, upload them to the cloud, and view them, query against them, et cetera, et cetera, et cetera. I'll put this next slide here, kind of to give a brief overview. If anybody on this call is feeling a little bit brave, a little bit of a visionary as to how these systems can kind of scale. What we share here is a university-managed model to encourage the building and the development of more and more digital health apps across all universities in the United States and internationally. We have here a model which we are testing at Stanford University, in which the university essentially defines each study and controls the security protocol of the VPC, the Virtual Private Cloud. The university then, Stanford in this case, understands the system, understands the studies, and understands what kinds of permissions the studies actually have. So this enables the entity to conduct faster data risk assessments. That's what the DRA acronym there stands for, as far as your study application and what it entails, what kind of risk can occur from improper handling. In this case, and under this model, the university also helps studies at a low cost. It helps them scale with premium features. If any study wants to use any kind of GCP feature at scale that comes at a cost, the university might be willing to subsidize it and share the cost of operation across multiple studies. I share this slide more so than anything to maybe spark a light and give a sense as to what some of the institutional pushes also look like to help universities adopt quicker frameworks, quicker serverless-based platforms to create digital health app quicker, more efficiently, and enable more people to do so by introducing beginner students to well-documented SDKs, such as the Firebase SDK, well-documented tools, well-documented programming languages, and well-documented processes. So very briefly, we saw the CardinalKit website, CardinalKit.org, up and running. Please visit our website, click through all the links, find what you like, leave comments, enter our Slack, et cetera, et cetera, et cetera. CardinalKit, as we've learned so far, is deeply rooted on all principles on open source software. In fact, when we're having individual contributors share code with us, work on studies, we ask them and we want them to kind of share their GitHub repository with us. Hey, what does your GitHub repository look like? Where are you trying to do this? Can you leave some comments as to where you want us to look? I would highly encourage that as well for everybody on this call and everybody who's building. If you're using CardinalKit, and even if you're not, head over to Discord, share us a GitHub repository to your working project and some of what you're building. You might unlock some really awesome support, kind of giving us the opportunity to come in and leave some comments, show where some innovations can happen, help answer questions, et cetera, et cetera, et cetera. We're very open to that. We live and breathe that model. Some of the frameworks that we use and we integrate into CardinalKit, such as ResearchKit and CareKit, and even the Swift programming language itself, are open source in many ways. This means that its code is publicly accessible. You can modify it, you can inspect it, you can enhance it, you can redistribute it under some terms and based on the license. This gives us the opportunity to be very confident about what we're implementing. And it gives you, as a developer, as a research, the opportunity to say, hey, I understand what ResearchKit does. I understand what CareKit does. I think it's phenomenal. I think it's great. I want to use ResearchKit to collect patient-reported outcomes. Maybe a year from now, you learn that there's something missing from ResearchKit that you really want. there's some kind of question that you want to ask your patients, and you can find how to do that using the current ResearchKit functionality. The great thing about open source is that you can download the ResearchKit code, modify it to your likings, add a new feature, and if you create a pull request and contribute that back to the ResearchKit repository under Apple, the CareKit repository under Apple, or the CardinalKit repository out of Stanford, I promise you all the maintainers of those frameworks will be so happy to see your contribution, so happy to see people innovating with it. They'll support it, help merge it in, and it really helped kind of close the gap as to how you could introduce your team and you as an individual contributor, how you could introduce an innovation in such a quick and easy process to the digital health space as a whole, right? So in a way, this session and this slides also serve as a knowledge transfer of what some tools that we can be looking at throughout the course of this hackathon look like. I share this slide very briefly. This is meant to symbolize a little bit of what CardinalKit hopes to allow everybody to accomplish. In this case, yes, we've discussed a little bit about accelerating rapid prototyping and giving you a scaffold, giving you tools, giving you a framework, giving you a GCP environment by which you could say, okay, let me focus on my surveys. Let me not focus on how exactly am I going to, build an iOS application or a GCP server on day one, right? We'll do that in a staggered approach. CardinalKit, we've measured and pushed to reduce the cost of producing an application by over $150,000. Of course, this is a variable number. It largely depends on your application. Part of what this is symbolizing and highlighting is actually the cost of engineering talent, product management talent. How much would you have to actually allocate a budget for to hire a team to build something out that you're envisioning? This is meant to kind of symbolize that, hey, actually, for a lot of studies, the tools that you need to be successful, here is a toolkit where you can get started for free. Maybe you won't have to pay as much to actually build some of the features that you want. That cost will go down by a lot. Likewise, timelines will go down too. We have here an average of 2 years to build the digital health study. We're proposing kind of reducing that by 12 months by having you actually be able to create your entire study application. You can create it in as early as a day. In as early as half a month, you could have your own brand, your own look and feel, your own surveys, you're collecting your own health kit outcomes, and you navigate it through the entire process. So now you get to spend the next 12 months testing the application with your patients, maybe adding a couple, 1 or 2 features that you didn't find there, making sure that the application is sturdy and ready to go, applying to the IRB, Institutional Review Board, to make sure that you can conduct a study with the participants that you hope to engage with, thinking of processes and how to be successful, a little bit less on the tech and more on really guaranteeing that your study will get you the right outcomes that you're hoping to collect. So we've seen CardinalKit. We've seen a phenomenal rundown of the framework, what comes with it. There's a couple bullet points here to the right to kind of summarize and give a little bit more color as to what the terms that we've set so far mean. And also, the next couple of slides will actually dive into these different areas that are bulleted here in a little bit more detail. So in the live demonstration that Varun shared with us, you saw a informed consent process right after you open your application. In CardinalKit that is built using ResearchKit, we'll see a little bit as to what else you can use ResearchKit for. We have a slide just for that. But you got the opportunity to go through this idea of, okay, I want my patients and my users to agree to some policies, and as far as, hey, this is the data that we're gathering. This is how us as an institution care about your privacy and how exactly you use your phone. This is what you should expect if you want to withdraw from your study. Your information may be deleted or not. ResearchKit lets you it gives you a set of tools by which you can confirm understanding with your patients as far as your consent process goes. And you can also add a couple of questions to your consent process. This is very, very flexible to your needs. You can say something like, hey, how old are you? And if somebody is, under 65, maybe you say, hey, actually, I'm sorry, you're not eligible for the study. You can continue throughout the consent process, right? Or you can ask any variety and breadth of questions. I think we thankfully we have some time. We will click through a little bit of what those actual survey elements look like, and give a little bit of an idea of how you can use those in your projects. CardinalKit also leverages CareKit. CareKit is a really powerful tool to track day-to-day adherence. So if you're looking to ask your participants, your patients, information about maybe some kind of medication that they're consuming, there's an example here actually on the screen, which is drink coffee. Not exactly medication, but you get the sense that you can ask somebody to drink coffee every day, to do so every other day. Likewise, for any other medication, you can schedule a program that works fairly well for them and kind of have that be a basis for your study. The third bullet point on the list, monitoring health data with HealthKit. You've heard some amazing rundown and feedback so far from Varun and from Mike. HealthKit is a really exciting piece that we want you to experiment. It lets you collect fitness data from a patient and from a couple of multiple sources. We'll share a little bit more about that. CardinalKit provides a set of tools and frameworks by which you can do that very quickly. You can modify the code and get to quote unquote get to market, collecting some fitness data, storing that on GCP relatively quickly. HealthKit also lets you collect electronic health records, and we'll also kind of share a little bit about the importance of that. CardinalKit also includes a core motion demo. This is alluding a little bit to what I shared earlier about this idea that it will help you collect pedometer data, accelerometer, device motion, gyro data, et cetera. It would help you stream it, and it would use Google Cloud Storage to accomplish that. CardinalKit also includes some awesome SwiftUI templates. We leverage SwiftUI heavily because it's a very didactic framework to build user interfaces. We think that you'll love it if you haven't tried it yet. It is very easy to learn. If you're new to SwiftUI, check out CardinalKit, actually, not just for digital health, but just SwiftUI in general. There's some applications here that you might be able to copy and paste on your projects. Again, open source. Use all these tools to your advantage. There is a zero code customizable configuration file, which is very powerful. You essentially have, let me open this up. You essentially have a one-stop file, a one-stop shop to customize all of your CardinalKit application. We got a really awesome sense from this, from Varun just now. I would encourage you to take a look at this file and take a look at what some of the things that it's adding here are. For instance, here we see something like your health data to read, and you can add some fitness data here: step count, distance walking, flights climb, heart rate. Now, what's really cool is that you can really easily say, okay, cool, there's a one-stop configuration file, and here's the name of the key: health data to read. How is this being used? How does this black magic work? You can easily go ahead and search the project, actually find that reference, click on it, and all of a sudden take a look at what some of the actual code reading those HealthKit quantity types look like. This gives you a fantastic opportunity to extend your knowledge on kind of what HealthKit can do. And if you follow up with your links in your documentation, you might be taken to something like this, where now you're learning about, here are all the different quantity types that I can collect using HealthKit. Some of these are extremely interesting: height, body mass, step count, distance, active energy burned from your Apple Watch, flights climbed, heart rate even, and so on and so forth. New metrics are being added all the time, such as some really awesome metrics, such as VO2 max and walking speed, and the 6-minute walk test distance, a passive HealthKit metric, which is quite phenomenal. just added very recently, and I can't wait to see what we kind of start to build using some of these metrics and monitoring some patient fitness data passively, right? A lot of this information can be collected after the patient consents to it. You can have a process where you say, great, you know what? Thank you. We'll go ahead and collect some information, a step count on distance, on the 6-minute walk test distance. And the patient doesn't even have to open the application for this to happen. This can occur 100% in the background throughout the course of the study. And it is your responsibility as a study coordinator to be able to provide feedback to the patient as to how they're doing, be able to measure these outcomes and really give the patient some excitement and some reason to be excited about the progress that they're making throughout their studies, throughout their projects, or throughout any kind of project that you might be building. Great. And of course, the biggest thing that we've shared is actually this GCP Firebase integration. You have a great starting point here as to when you download this code and when you copy your plist file from your Firebase configuration to it, it will start sending information all over your Firestore. And a couple of databases actually. We'll take a look at what those look like, and you get that right out of the box. You can modify it in any way. But at least you get a sense as to how it might work. So I'll take a couple of slides here to kind of share where everything is going and a little bit also of what is everything. Here we see ResearchKit introduce this as a kind of the open source frameworks to let researchers conduct surveys. Every survey that you run through ResearchKit and CardinalKit, the results are automatically parsed, converted to a JSON object as to Apple serialization standards, and uploaded to Google Cloud Storage right off the bat. What exactly is ResearchKit collecting? We just saw a little bit of the consent process, and I invite you very heavily if you want to build any kind of consent process for your applications. This is something you might look at. You might look at the CardinalKit and ResearchKit consent process, and rest assured that after that consent process is finished, there's a record sent to Firestore that this has been completed with some information. Same goes for any kind of survey. This is really important when you're planning and thinking about how to collect feedback from your patients, collect patient-reported outcomes. What kinds of questions can I ask and why? We saw some really cool demos actually just now from Varun. We saw a couple of surveys that were conducted that serve as a phenomenal example as to what do your questions look like? What can you actually add? How can you ask these questions? Not only that, but again, the consent process itself is a ResearchKit task with a set of steps. So it is a survey with a set of questions, essentially. The consent process itself is do you agree to this? Do you agree to that? What is your name? What is your signature? And you can add more questions to that. What is your age? What is your age? When did you have the most recent surgery? Et cetera, et cetera, et cetera. And then here we also have from ResearchKit the ability to conduct and collect active surveys. Active surveys measure body activity using sensors, motor activity, fitness, cognition, speech, hearing, hand dexterity, vision, et cetera, et cetera, et cetera. They let you take a picture. We have here an example of an active task measuring your gait and balance. So this task asks you to walk for 20 steps. Of course, if this being a simulator, it doesn't actually have a pedometer where we can measure that. However, what we can do is show a little bit of what all the ResearchKit active tasks look like. Highly encourage you to dive into ResearchKit open source documentation so you can get a sense of what active tasks you can use and how you might implement those. What exactly does it collect and how CardinalKit can help you get all this information onto the cloud right off the bat, essentially. And let's go ahead and actually stop this. There you go. So you have those two examples right there, kind of baked in and built. I also want to share a little bit of a snippet. This is there you go. This is an application called the ORK catalog. You will find this on the ResearchKit open source code. This is the ResearchKit open source code. I went ahead and downloaded it from GitHub. Here we see ResearchKit. And when I download it, I can see that I can launch a couple of pre-baked applications: a Parkinson's study, a sample study, a test study, and the ORK catalog that we reference a lot throughout CardinalKit. The ORK catalog gives you a very concrete sense as to what questions you can ask using ResearchKit. What does the format of those look like? Why might you want to use these? Not only that, but the ResearchKit catalog, you have access to the entire source code. So there's nothing stopping you from grabbing all the implementations of the surveys and all these questions and just copy them into your project, modifying them to your needs, understanding kind of what you see here and getting started with it really, really, really quickly. Here we see a form. In fact, all of these questions, most of them at least on the code base that we see here in ResearchKit, is written with Swift. So you can easily kind of grab, copy paste, maybe change a couple identifiers or references to constants that are no longer there, and then you're off to the races. A couple steps to kind of view a PDF with a full example of how this works. You might want to do this to show the patients their consent they just signed, or some kind of study procedure halfway through the study. Anything that you can think of, you name it, there's a way to do that. And here we also see kind of the logging process that Varun took us through, the account creation process, the process of obtaining consent, and it should be all here, ready to be available for you to use and leverage when you're building your applications. Great. I think we went through all of this. Let's move on to a new topic, that is that of HealthKit. We talked about HealthKit really briefly in the context of how it lets you collect fitness data, step count, flights climbed, heart rate, calories burned, you name it, a lot of metrics. We saw a full list just earlier. Also, electronic health records, which are very important now more than ever, thanks to, as Dr. Aalami was describing, the 21st Century Cures Act and this push towards letting patients from a legislative level become the owners of their own health records, let them take it with them, let the patients decide who they want to have access to those health records and what to do with them. So they own a copy. The iPhone makes that really, really, really easy. And CardinalKit has some code for you to leverage this right off the bat, and have your patients be able to report some of their health records to you in your studies and throughout the course of your studies. If you want to do this, you're going to want to look at how to use HealthKit, and I encourage you to take a look at CardinalKit's implementation to help you get started. HealthKit itself is very powerful in a way that is a stored of health fitness data for kind of Apple's internal sensors, a pedometer, accelerometer. There are other apps that also and can also add information onto HealthKit, including your own app, and including your own external wearables. So any app or any wearable that uses some kind of onboard technology, measuring raw sensor data, anything, you name it, to make some kind of assessment or reading about your fitness outcomes. So all of a sudden, and I know here we're at MIT, if anybody has ever worked on a project where you create an external wearable and now you have this wearable collecting or measuring the step count of a patient, and all of a sudden your wearable is one of the most accurate ways to measure step count known to man, you can report that information back to HealthKit. And by doing that, you kind of start to democratize it. You start to make it available for any iOS app, which CardinalKit kind of leverages this model to let you say, okay, knowing that, let's go ahead and grab anything from HealthKit and provide you a way to upload it to Cloud Firestore and the Google Cloud Healthcare API. And CardinalKit growing over time, providing more methods, more ways to visualize and analyze this data. Hopefully this gives sense as to not only our roadmap, but what some of this pipeline looks like and what you can do today to be really efficient with your health information on your apps. Let's see, wrap up in about 4 minutes. So I'll click through. I have about 3 more slides, almost done. We have here also CareKit. We shared a little bit of CareKit, this idea of tracking day-to-day adherence over a period of time. This uploads directly to Cloud Firestore. Let's take a look at it, actually. We have CareKit over here in our app. Oops, sorry. There's some clicking from my trackback to the simulator. Great, here we go. Ask me for my passcode because I left the app. Verify that I am me. And here we have 2 tabs on the CardinalKit application. We have a contact tab where you can put information about yourselves and your study coordinators. Here we have a schedule tab where you can actually schedule content day by day. I'll put here the code in the background as I'm talking, where you can actually see how we grabbed the task to drink coffee. And we said, okay, this task, why don't we go ahead and schedule that at an interval of every day? So every day I want to drink coffee. And here we go. Here we have our task. Every day I want to drink coffee. Every day I want to drink coffee. This is for your patients. This is how you schedule them to do something effective. When they go ahead and drink their coffee, you can see their completion kind of pop up thanks to ResearchKit awesome implementation. You can also get a sense of, I want to ask a patient to walk 2,000 steps a day. And here's how you can measure it. When the patient hits this goal, this little indicator will go up. You can also ask a survey to a patient every day or every other day. In this example, we asked to take a survey every single day. And you can create that survey. When your patients actually like that survey, how are you liking CardinalKit a lot? That survey shows up as completed, and our little indicator icon populates to kind of show that process. This lets you schedule a progress from your study participants over time and let them give them a framework by which when they have to complete kind of different features, different innovations, different technologies. And I'll share that the entire iOS ecosystem is open to you here to innovate. So you can start to integrate internal kind of local push notifications or something else to alert the user that they're due for something. Have them interact with it. All these tools are open and available and readily at your disposal. The CareKit is very new to CardinalKit, so this will be growing over time and getting even better. We just added this, and we'll continue to support it. And then we talked a lot already about cord motion. Really briefly, I think one main key point or takeaway from CardinalKit is that your sensor data is streamed as it's happening, packaged into multiple zip files, processed even if you're offline, and then ultimately added to Google Cloud Storage. So you'll have a copy where you can actually see on Google Cloud Storage some of that data coming in as your study participants are going about their day-to-day. Cloud storage is different than Firestore, so we have a couple of different databases by which we send data, and we will actually be adding more over time, such as the Cloud Haircare API, et cetera, et cetera. So I'll stop there. I know I'm about at time. I'll stop by sharing this little slide here. This is the message about the Google Cloud Firestore database and kind of how we handle rules. This is a rule set that you can use to protect the information in your database so that it's only accessible to the users that are logged in at the time. They can only write or read documents that are under their collection and account. I want to leave this here because it's only pertinent to CardinalKit because CardinalKit enforces the collections at which data is written. When you're creating your applications, you have to make sure to be really careful about what collections you're using, where data is going, and modify this rule set or your own rule set accordingly to make sure that other users don't have access to other users' data. Hopefully, this gives a last kind of sense about how HIPAA compliance is also in your hands to make sure that you secure your applications and build them in a responsible way. Thank you, and I'll pass it back to Dr. Aalami.
Perfect. Thanks, Santi. Why don't you stay on? I'm going to just read a few questions that came up. That was a great review. So one question that came up was, is this framework restricted to the Swift language? Would you be able to use Flutter, for example?
This framework is restricted to the Swift language, absolutely. In fact, the reason for that is because we leverage the iOS ecosystem to kind of advertise and create open source tools within it, namely ResearchKit and CareKit. However, if you wanted to use Flutter, I guess the con is that you miss out on some of this kind of features that are baked and pre-built out of the box. But you'll be creating a cross-platform experience for iOS and Android. And you know these concepts from CardinalKit. Try CardinalKit, run it, check out the concepts. What is consent? What is CareKit? What is HealthKit data? If you want to build similar concepts using Flutter, that's phenomenal. You're probably onto something really great. You'll be innovating something really clever and organize yourselves around the concept of I have to implement a consent process, a HealthKit process, day-to-day tracking, right? How you might go about that is by leveraging the same architecture that CardinalKit and ResearchKit does to collect this kind of survey-based task and step, survey and question-based architecture to create something from scratch.
Great. A question that always comes up, Santi, I feel like during our workshops is, number one, do you need an Apple developer account? And then what are the costs associated with using CardinalKit? Let's say if you don't have a GCP account, you don't have an Apple developer account, do you need one?
If you do not have an Apple developer account, you will not need one to get started. But if you choose to use passwordless login, so if you used to enable dynamic links and set up a passwordless login approach, this will require you to have an Apple developer account that's valued at around $100 a year. While you're testing your apps, I will say there is a way to do it for free. If you already have an Apple developer account and you want to go passwordless, that means your patients get an email and they click on it and they're automatically logged in. Great, power to you. We highly encourage that. There is a cost associated with using GCP in general that kind of changes as per your individual studies and what you're working on. I think for the purposes of your build-a-thon, you could assume that everything that you're doing will be free and covered.
Yeah, and we'll be giving Google Cloud credits to all the participants who have registered for this hackathon.
All right. That's fantastic. Thank you for adding that. Another really important question came up about accessibility, Santi. What is being done or how can we best address accessibility, let's say in the face or in the terms of disability? So for the visually, auditory or tactile limited folks, for another one would be, are there telephone-based access features that can be turned on or off to help with accessibility? Any comments around that?
I would share kind of a brief overview that at least in CardinalKit specifically, there are features that you can turn on and off based on your individual needs. Either way, accessibility is an extremely important point. CardinalKit leverages the accessibility best practices baked into ResearchKit, which is a framework built by Apple, baked into CareKit, which is a framework built by Apple, baked into HealthKit and Core Motion APIs, mostly HealthKit, also built by Apple. CardinalKit doesn't have accessibility harnesses built in from scratch, although, and we'll invite you to do this. This is a potential project for your build-a-thon as well. The idea of building into CardinalKit a process to read out the consent to somebody who might be vision impaired, to read out their CareKit plan and what they have to do day by day, and to read out exactly how their data is being protected and cared for and how their progress is on their study. Just using Apple's kind of synthesis speech APIs and a couple other tools, you might play a little bit with iOS accessibility features and find a good marriage of how to use CardinalKit along with those, create a video kind of documenting the process, highlighting all of those as potential processes that you can go beyond to establish really good accessibility best practices.
I think that's a really important question. And one elephant in the room is that we're kind of severely limiting ourselves to the iOS ecosystem. And we're fully aware of that and its limitations. And, would love it if, when the Android ecosystem kind of gets to the point of, and I know a lot of work is being done, such as the Common Health application to get it, just implement the Smart on Fire API. But it was just for us, with our kind of within our ecosystem, within our environment, We feel like that the tools available make it super easy. We even have a transplant surgeon at Stanford who literally is built his own. He came up with a device to go and analyze liver sections, when he's harvesting a liver for transplant, to use AI and computer vision to do an analysis of that tissue slice to see if it's amenable to transplantation or harvest. And he's building his own application using CardinalKit. So, that was our goal, is to really lower the threshold. You still need to learn, obviously, some developer, or you need to have some developer school skills. But we're trying to really democratize this as much as possible.
And on that note, anybody interested in Android development, you have the concepts here: informed consent, research, surveys, right? Surveys at patient-reported outcomes, and maybe even day-to-day adherence. You can get started with just those 3 points, building a really powerful Android application, and you will probably be benefiting a lot of the digital health space, a lot of CardinalKit, a lot of researchers that want to use Android. That's another potential project to consider.
Right. There's Michael keeps asking questions about accessibility, and I'm very empathetic to his questions and the need. And, out of the box, iOS has done, I must say, quite a bit to try to make things as accessible. I love your passion, Michael, and I 100% urge you that, whatever project you work on, we're giving you a starting point. Think of the millions of ways you can build on top of that starting point to make, to add more accessibility, and you would bring tremendous value to the world. So I totally, I hear you, Michael, and it's a huge need. And like I said, out of the box, iOS has many features, like increasing the text size, reading back every page. They have some Braille things that have, they've worked into for the blind. So it's just keep focusing. But any other questions that you can think of, Santi, that are pretty common? We only have 2 questions. I do want to add real quick, though, that we will have a CardinalKit kind of prize at the end of the hackathon for the best CardinalKit implementation. So think about that. And I posted all the resources to our website in our Slack channel. And we can continue to take questions. And for office hours, the best thing is to email or to post here on the Slack channel. And also, I will provide Varun's email. He has agreed to provide some support asynchronously, and we'll also pick a 2-hour slot this weekend to provide support. And thank you, everybody. I know we're almost done here, so might as well end it.
Perfect. Thank you so much, Oliver and Santi. That was awesome. They've done some phenomenal work, so I encourage you to check it out. And we are offering a prize for best use of CardinalKit, so keep that in mind. Now, that is a wrap for day 3 of our Tech Talks. Tomorrow, for day 4, we do have the Google Cloud Healthcare and Life Sciences team. They will walk you through the Cloud Healthcare API, the functionality, talk a little bit more about FHIR. Then we'll also do a deep dive of the NLP API, natural language processing, and we'll talk about the data protection toolkit. So I am signing off for today, and we'll be hanging out on Discord throughout the day. So feel free to message me in Discord with your feedback. I really want to make sure these talks are as useful for you as possible. So let that keep that feedback coming. And I want to make sure that you're set up for success. So see you all tomorrow. Thank you again for joining. Bye now.